and CCNP. He has published more than 100 research papers in various renowned international conferences and SCI index journal, including Journal of Network and Computer Application, wireless networks, wireless personal communications, sustainable cities and societies, and emerging transaction of telecommunication. He has contributed with more than 30 books, chapters in various books, and has edited 15 books from the most famed publishers like Elsevier, Springer, Wiley, IOP Press, IGI Global, and CRC Press. He has served as keynote speaker in numerous reputed faculty development programs and international conferences held in different countries, including Iran, India, Morocco, China, Belgium, and Bangladesh. He has served as a reviewer, editorial, board member for several reputed international journals. In the past, he worked as an assistant professor at HMR Institute of Technology and Management, New Delhi, and network engineer in HCL Infosystem Limited, Noida. In the year 2021, Stanford University in US listed Dr. Bharat Bhushan in the top 2% scientist list. In addition to being the senior member of IEEE, he is also a member of numerous renowned bodies, including IAENG, CSTA, SCIEIE, IAE, and UACEE. So we have a personality who's not just a person who's into academics with distinction as mark, but has also served as a journal, also served in numerous journals. His contributions are immense, and it's a privilege and a proud moment to be present and witness to listen to Dr. So, Dr. Bharat Bhushan, now I give this dash to you, so you can take over from now. Thank you. And before we start, I would like to let everyone know that we would be taking question session. That would be at the end of the session. So, it's yours now. Thank you.
Yes, good morning, Professor Sadadal. Am I audible?
Yes, you are audible.
Yes, sir, you are.
So shall we start?
Yes, sir. Yes, sir.
Is my screen visible?
No, sir.
No, no, no.
It's visible now, sir.
Okay. So, good morning, everyone. Today, I'll be presenting the need for blockchain technology. There is a technology called blockchain that we all are talking about. But why this blockchain is needed for this data privacy, and an important term called cryptography. So, what is the need of cryptography in blockchain technology? So, we'll be seeing a discussion on this thing. So, first of all, we'll see a formal definition of blockchain, and then how this blockchain technology is different, or what is the difference between this blockchain and the traditional database that we use. And after that, we'll move towards the blockchain transaction lifecycle. And this blockchain transaction lifecycle we'll understand with the help of an example of Bitcoin cryptocurrency. Then we'll move towards the blockchain architecture and classification of blockchain technology. And while studying all these topics, we'll be exploring actually the role of cryptography. What role this cryptography is playing in the execution of the transaction using blockchain. And then, if time permits, we'll see some problems in IoT and blockchain-based IoT application areas. So talking of blockchain, what actually is a blockchain? We all know what is a linked list, isn't it? So in the linked list, what we have several nodes, and all those nodes are connected to each other in a linked list. So basically, the connection between the nodes in a linked list is done on the basis of memory addresses. All the nodes are connected to each other on the basis of memory addresses. However, here in blockchain, again, we have similar to nodes, we have blocks here in blockchain. Like the nodes are connected in the linked list, similarly, blocks are connected here in blockchain. However, this connection between the blocks is not done based on the memory addresses. We have something else to connect these blocks to each other. Overall, it is similar to a linked list, you can say. Basically, the blocks are connected to the previous block with something called hash. The linking that we have here in the blockchain thing, we call this as hash linking. So we'll see this hash linking in detail in our further slides. So blockchain, you can say it is a type of data structure. It is a distributed type of data structure, rather, you can say. Why distributed? Because it follows a distributed architecture. We'll see this distributed architecture very soon. But before that, this is a definition of blockchain that aggregates four important components, you can say. I have aggregated this definition as a blockchain is a decentralized computation and information sharing platform. Very important. Blockchain is nothing but it is an information sharing platform that enables multiple authoritative domains who do not trust each other to cooperate, coordinate, and collaborate in a rational decision making process. So, this is a formal definition of blockchain, you can say, and it consists of four different parts. That's why I have highlighted this in red for you. First one is decentralized. Second, information sharing platform. Then we have multiple authoritative domains. And the fourth term is rational decision making process. So we'll understand all these four terms one by one, first of all, before we arrive to a formal definition of blockchain. So first term is the decentralized computation. So what do you mean by decentralized? Initially, we had centralized architecture where one central coordination system was there, and all the nodes were connected to this central coordination system, and they receive order from these systems and they perform the execution based on these central coordination system. However, what happens if this central coordination system fails? If this central server will fail, all the other node will lose connection. So if the server fails, all the node will lose connection. So this centralized architecture, basically we can say it is susceptible to single point of failure. Therefore, in order to overcome this problem of single point of failure, central point of failure, we can say, so we have a decentralized architecture. What happens here? Again, we have several coordinator nodes in this decentralized architecture. All the coordinator nodes are connected to each other, and the individual nodes are connected to these coordinator nodes. Instead of having one central server, one central node coordinating all or connecting all, we have several coordinator nodes here in decentralized architecture. So this problem of single point of failure is overcome here in decentralized architecture. So we can say the decentralized architecture works even under several failures. So blockchain basically uses a type of decentralized architecture. We cannot say it completely uses a decentralized architecture. Have a look. The first diagram is a centralized network where all the nodes are connected using under a single authority. There is a single central server that connects or coordinates with all the nodes. Then we have a decentralized network where we have, suppose, 6 coordinator nodes, and every coordinator node is controlling some of the normal nodes or the peers. So the peers are under control of some coordinator node. Suppose what happens if, suppose, this is the coordinator node and these are the peers with it. If suppose this coordinator nodes fail, what will happen? These 5 peers that are dependent on these coordinator nodes, they will connect to some other coordinator nodes based on the requirement, based on availability. They will be connecting to some other coordinator. So suppose there is failure of some coordinator nodes, it will not affect the entire system. But blockchain uses a advanced version of decentralized network, you can say, where in decentralized network only the coordinator nodes are connected to each other. In blockchain, the coordinator nodes are connected to each other, and also all the nodes are connected to each other. So every node is connected to each other in the decentralized distributed network. That is an enhanced type of you can say decentralized network. So blockchain uses a distributed network. So this is the first term, decentralized computation. Second term was information sharing platform. So what do you mean by information sharing platform? Suppose there are two persons. Initially, what we had, suppose two persons, Bharat and Bharti, they are working on a common project. So initially, what was the traditional way of data sharing? Suppose Bharat will write some document in his MS Word and he will send it to Bharti. And when Bharti will read this MS Word document, and she will be able to find some problem or do some editing, and she will send it back to Bharat. And both of these people can, work on this single project at a time. But what happens? What is the problem? When Bharat was writing the document, Bharti was sitting idle. And when Bharat sent the document to Bharti, Bharti is reading and correcting the document, Bharat is sitting idle. It means that both Bharat and Bharti is not able to simultaneously edit the document. So this was a problem in traditional way of data sharing. Therefore, we moved on to shared Google Doc. So what is the shared Google Doc? What feature it provides? It provides that both Bharat and Bharti can edit the document simultaneously, and they will be able to see the most updated copy of the document. So this overall, both Bharat and Bharti can simultaneously edit the document. But however, you can see that this type of shared Google Doc is also susceptible to single point of failure. Because why? Because suppose this shared Google Doc is lost, what will happen? Both the Bharat and Bharti is depending on this central Google Doc, say shared Google Doc. If this document is lost, this document will be lost from both the ends. So this is a problem here. You cannot say blockchain is a type of Google Doc or MS Word file, but this example will help you understand one feature of blockchain, that is information sharing. And I will form a base. This example will actually form a base on understanding the concept of public ledger, the concept of local copy, and how these things are interrelated to each other. So this shared Google Doc was susceptible to single point of failure. We have the blockchain way, ideal solution, how blockchain actually works. Suppose Bharat is having his own copy, he can edit in his copy. Bharti is having her own copy. She can edit in her own copy, and both these copies are exchanged. Both these copies are synchronized and reflected into the central server, central cloud. Means Bharat has his own copy, Bharti will have her own copy. They can independently write their personal copy. What blockchain does, it ensures synchronization of what they are doing. So both will be able to see the most updated copy. Both can simultaneously read and write the document. And also, suppose this central cloud is lost, central server is goes down, what will happen? Even if the central server goes down, both Bharat and Bharti is having a copy of the most updated version of the document. So they are having the most updated copy of the document with them. So information loss is also not there. So this is actually a type of blockchain type of solution for this MS Word and this shared Google Doc. What happens? This copy that Bharat and Bharti is maintaining, this is called a local copy. If you consider this definition of blockchain, you will say that these two copies that both Bharat and Bharti is maintaining with them, their end, on their end, these are the local copy. And the local copy is being reflected on the central server. We can relate the central server with the public ledger. What does this public ledger do? It reflects all the transactions that have been, taken place, So this central server acts like a public ledger. So this is how a blockchain is a information sharing platform. And who shares the information? Multiple domains, multiple authoritative domains, multiple peers, you can say, multiple nodes. For example, here we have 6 different nodes. As I said, both Bharat and Bharti is maintaining their own copy. All the 6 nodes here will maintain their own copy. We call them a local copy. So every node will maintain a local copy, and this information contained in this local copy will also be reflected here in the central server, here in the public ledger. The database of historical information available to everyone, we call it a public ledger. So this is reflected in the public ledger as well. So in order to ensure consistency, the local copies at every node is identical. Whatever we have at one node, that will be reflected in all the nodes. And these local copies are always updated based on the global information. So it is not that first local copy is updated, it is the local copy is updated based on the public ledger, based on the global information. Then we have a rational decision making. The last point in this definition was rational decision making process. So what is this rational decision making? This is nothing but making correct decision. What kind of correct decision you want to make here with the help of blockchain? Let's have a look. Suppose there are 4 friends, Bharat, Bharti, Eve and Vector, and they want to do some kind of transaction among themselves. They want to share some, for example, money or cryptocurrency or whatever for that matter. Initially, everyone knows that Bharat is having $100 with him. So the Bharat is having $100 is with him is reflected in the local copy of all the 4 users. This rectangle actually here denotes the local copy of all the users. So this information is also reflected in the public ledger of everyone. Then suppose Bharat wants to send some dollar to Bharti. For example, Bharat wants to send $50 to Bharti. So he will send $50 to Bharti. See, sending $50 is not that easy. There is lot of story behind sending this $50 to Bharti. We'll have a look at this story also. At this point of time, suppose Bharat wants to send $50 to Bharti, let him send. Let him send. Suppose he had sent this $50, what will happen? This transaction of Bharat sending $50 to Bharti, it will be reflected in the local copy of all the users. So every user will know that Bharat has already sent $50 to Bharti. In the next step, suppose Bharti wants to send $30 to Eve. So what happens? Bharti will now put a request. How this thing is executed, she will put a request ki I want to send $30 to Eve, and until and unless all the users, all the peers in the network agree to the fact that Bharti is capable of sending $30 to Eve, this transaction will not be guaranteed. granted. So Bharti first initiates the transaction, means in blockchain, initially a transaction is initiated, and then based on the response of all the users in the network, the transaction is either granted or the transaction is denied. Suppose this transaction is of $30 is granted, what will happen in the next slide? What we will see, we will see another transaction being added in this local copy. So we have Bharti have sent Eve $30, okay, and this is also executed, so it is reflected in the local copy. Now we can say that whenever a transaction is granted or whenever a transaction is executed completely, then it is updated in the local. Now suppose Bharat wants to make a new request of $80, sending $80 to Vector. Now, should Bharat be allowed to send $80? Everyone in this network knows that initially he had $100. He had already given $50 to Bharti. Now he is left with only $50. How can he send $80? So this transaction will be denied. This transaction will be denied by all the users. And if this transaction is denied, I said, after a transaction is denied, it is discarded. It will not be added into the local copy or the public ledger. So this transaction is denied, not updated in the public ledger, and local copy is dependent on the public ledger. Therefore, this transaction will not be reflected in the public ledger of any user also. So this is how we make correct decision. And the blockchain focuses on replication, data integrity, and consistency, and this process by which all the users, all the four users, reach to some kind of decision, reach to some kind of correct decision. We call it a response, we call it a consensus response. So reaching to a correct decision collectively, we call it, the process is called consensus. So consensus is nothing but it means that everyone agrees that the data that goes into the data structure is what they agree to put there. It means that whatever everyone has agreed, that is only put into the data structure, rest everything is discarded. So this is consensus, very important word in terms of this blockchain. And like I said initially, blockchain is a type of linked list. Here the linking is done on the basis of a cryptographic technique. We call it a hash linking. Very, very important topic. We'll discuss in detail right now. Moving on to the, with this such understanding, we can move towards the formal definition of blockchain, that is open distributed ledger that can record transactions between parties efficiently and in a verifiable and permanent manner. We know open, distributed, and efficient. Verifiable because everyone can check the validity of information. Permanent, very important. Whatever information you have entered in a blockchain, so that information is persistent and tamper proof, means whatever you have entered, you cannot update in future. So the entered information cannot be updated, and also the committed transactions, means the transactions that have been executed, granted and executed, cannot be rolled back. Means that cannot be, we cannot move back, we cannot deny after doing some executing some kind of transaction. So the committed transactions can never be rolled back, and the information is persistent and tamper proof. With these two important features, the blockchain technology has gained importance nowadays and is used in huge range of application areas. Talking of a difference between a centralized architecture and a blockchain, for example, here in the centralized architecture, suppose there is a user and he wants to access the data X, he will send a request, yeah, I want to access data X. And the central server, the trusted third party, will send a response to this user. Yes, based on the permission, based on the privileges assigned to this particular user, the centralized server will send a response to the user whether you can access the data or you cannot access the data. So this is the centralized architecture we all know. In blockchain, what we have? The user will make a request. Can I access data X? The peers in the network will decide whether this user should be granted. So they will collectively decide and reach to some kind of conclusion, reach to some kind of consensus, and the blockchain network, instead of giving a normal response, gives a consensus response that takes or consults each and every user, each and every peer in this network. So there's a basic difference between centralized architecture and the blockchain based architecture. Talking of the difference between a traditional database and a blockchain, we have centralized architecture in traditional database. However, blockchain uses decentralized storage. Then in traditional database, we need a database administrator to manage all the stored data. However, in blockchain, we don't need any administrator. Everyone is an administrator here, and you can say, in other words, nobody is an administrator. Means everyone is permitted to make a request, but it is not guaranteed that all the request will be executed or all the request will be granted. So everyone is an administrator because everyone can make a request. Nobody is administrator because this request made by anyone is not guaranteed to be granted. So there is no need for administrator in a blockchain. Modifying data requires permission. Here, no permission is required. If you want to modify in your local copy or raise a transaction. And until and unless everyone in the network agrees to the fact that you can modify this data, or this transaction is can be granted, it will not be granted. So it depends on the consensus response from everyone. So centralized databases keep information up to date. However, blockchain, as I said, keeps the present information as well as the past information. Traditional database, we use a database as a database. However, blockchain is not feasible if you use it as a database. It is a transaction platform, information sharing platform, you can say. So the performance will definitely degrade if you want to use blockchain as a database. So this is the difference between blockchain and traditional database. Moving on to very important thing, how a transaction is basically realized in this blockchain network. So here I have taken an example of Bitcoin. How a Bitcoin is credited. What is the story behind crediting of Bitcoin in someone's wallet? So suppose there is two person, Alice and Bob, the well-known names in most of the cryptography books. So suppose Alice wants to send some data, some Bitcoin to Bob. So what will Alice do? She will initially open her Bitcoin wallet. In the first step, you can see the Alice opens her Bitcoin wallet. Okay. Once she opens the Bitcoin wallet, she needs to give two things. First one, address of the receiver, means address of the Bob, and how much amount she wants to transmit. So the amount to be transferred and address of the Bob, and she will click on the send button. Now, this clicking on the send button means Elise has initiated a transaction. I want to send this much amount to Bob. Elise has initiated a transaction. And once the send command is given, what will the wallet do? Wallet will construct a transaction, and it will digitally sign using its private key, and it will broadcast this transaction to the network. So Alice wants to send this amount to Bob, is broadcasted to the entire network. Why? Because all the nodes in the network will now validate this transaction, whether Alice is capable of sending this much amount to Bob or not, whether this transaction should be granted or it should be denied. So the network nodes will validate the transaction. How will they validate the transaction? Based on the existing status of the blockchain. And if this transaction is okay, if everyone finds that this transaction should be granted, no worries in this transaction, this transaction is sent to the miners. Who are miners? Miners are nothing but the special nodes that actually try to associate the newly created block to the existing blockchain. We'll see it later. What is a miner? So what the network nodes do, they assign this transaction to the miners. Now, it is the responsibility of the miner to take this transaction, include this transaction to the next block to be mined. So, blockchain is a series of blocks. Now, there is some new block also that is getting created, and that will be added to this chain of blocks. So miner, what it does, it takes so many transactions and it creates bundles them into a block, and it also associates this block to the existing blockchain. So the miners actually include the transaction to the next block to be mined. So they collect all the transactions, construct a new block. As I said, say they will take transactions from several people, construct a new block, and once this new block is constructed, this new block needs to be associated with the existing chain of blocks, and this connection between the new block and the existing chain of blocks, this connection is done based on cryptographic hash function. So this connection, connection of the new block to the existing blockchain, it is done on the basis of cryptographic hash function. And once this is associated, once the block that consists the newly created transaction, once this is associated with the existing blockchain, we say mining is complete. So once the mining is over, the block is included in the existing blockchain and updated ledger is propagated throughout the network. And based on this updated ledger, the local copy of all the nodes get updated. And then after the local copy is updated based on the public ledger information, when Bob will open his Bitcoin wallet and he will refresh, his local copy will get updated. The public ledger is already updated. Therefore, the blockchain, the entire blockchain is updated. So the transaction will get reflected in the Bob's wallet. So this is how actually Bitcoin is credited and debited from one's account to the another account. So have a look at this pictorially. Initially, a transaction is requested here. So someone has requested a transaction. I want to send some Bitcoin, some cryptocurrencies to some other person. What will happen? This requested transaction is broadcasted to the peer-to-peer network. So this transaction is sent to everyone present in this network. And all the peers, all the nodes in this network will validate this particular transaction, and based on this validity, if everyone has validated this transaction, it will be bundled into this block. See here, all the four nodes have said that this transaction is valid, so this transaction is sent here. There are some more previously existing transactions, so all these previously existing transactions and the new transaction are bundled into a block. So here transactions are bundled into block, and this block is again bundled into the series of blocks. So here have a look. The verified transactions are combined into a block, and this newly created block is then added to the existing blockchain here. And this linking is done with the help of a cryptographic hash. So what this transaction is, basically it can be anything. For that matter, it can be a cryptocurrency or contract or record or any other information for that matter. So this transaction is combined to form a block added to the blockchain. So this transaction is completed, the public ledger is updated. Let's see, the transaction initiated, broadcasted to the network for validation, and the miners will verify the transaction, bundle them into blocks, and once they bundle them into blocks, they race to solve a cryptographic puzzle. Now this is very important. There are so many nodes. So which node will actually perform this addition of block into the existing blockchain? So for that matter, what happens? The nodes actually race to solve a cryptographic puzzle. They are given a cryptographically complex puzzle, and whoever solves this puzzle, first, that particular node will receive the opportunity to add this new blockchain to the new block to the existing blockchain. Okay. Now, solving this cryptographic puzzle, they use some kind of energy, you can say, some gas. We say it is a gas, so they use some resources here, so they also receive some incentive. Therefore, all the nodes race to solve a cryptographic puzzle, and they receive incentive in this in response to that. And the winner of this puzzle will add the block to the chain, and once it is added, it cannot be altered, we had seen, and every node will receive a copy of the updated chain. So these are steps involved in a Bitcoin transaction. Talking of the architecture of a blockchain, we have seen that blockchain consists of several blocks, and the blocks consist of several transactions. Very important here is the block n is linked with the hash of block n minus 1. Block n plus 1, you can see, is linked with hash of block n. N plus 2 is linked with blocks of n plus 1. So what it is actually saying, they are linked with hash of their previous blocks. So these blocks are identified by the cryptographic hash, and every block references the hash of the previous block, and this way this actually creates a chain of block here in blockchain. So for example, the first block or the parent block, we call it a genesis block. So this genesis block have some data and it has some random hash, you can say some random hash. Based on this data available and this random hash, this genesis block creates some hash, let's calculate some hash. Now, this hash in this genesis block is used to calculate hash in block 2 based on the hash of the previous block and the data. So block 2 is having data, for example, Tuesday, and they uses the previous hash calculated by the genesis block, and based on these two value, based on the first two rows, third row is calculated actually. So based on these two values, this value is calculated. Now, this value calculated is used by the block 3, and this, it means that this value calculated in block 3 uses this, and this is dependent on these two. So if suppose you change somewhere here, you have to change all the preceding blocks, because all the block is linked to each other, because all the blocks are using the hash value of the previous block. Block n is dependent on n-1, n-1 dependent on n-2, and so on. So what happens, if you want to change or tamper some blocks, you will have to change all the blocks for that matter. So for example, an adversary or malicious user or an attacker wants to, tamper some block, so he will have to tamper all the blocks, and the complexity is increased to such an extent that till you tamper all the blocks, some new block will get created, and the adversary will never be able to reach to the last block. Therefore, we say that blockchain is very, very secure, because adversary cannot compromise all the block at the same time. And even if he or she tries to compromise all the blocks, some new block by then will get added by this miner. Therefore, again, everything will get updated. So this is the problem here for the attackers. Therefore, blockchain is very much secure. And here you can say, apart from the transaction, see, we said that a block consists of several transactions. So we have transaction 1, 2, and all these transactions are bundled in the form of block added to the existing blockchain. The block consists of two components. First one is the header, that is means information about the data, that is the metadata. For example, it has nonce, n bits, timestamp, Merkle tree, root hash, parent block hash, and block version. And then we have the block body, that is nothing but the aggregation of all the transactions along with the transaction counter. So these are the two components of the block structure. Core components of blockchain, we know, we have seen this transaction, we have understood the consensus, we know what a blockchain is. Moving on to very important thing, that is asymmetric key cryptography. So where is cryptography used in blockchain? So initially there are three phases, you can say, in order to understand this blockchain. There are three phases basically. First one, when a transaction is initiated and it is broadcasted to the entire network. So there's a first phase. Once the transaction is initiated and broadcasted to the network, we have to validate this transaction. So second phase is validation of transaction. And then third, once this transaction is validated, we have to chain this transaction in the form of a block and add this block to existing blockchain. So initiation and broadcasting of transaction uses digital signatures and public and private keys. That is the concept of cryptography. For validation, we have consensus mechanisms. There are a number of consensus mechanisms. You can say proof of work, proof of capacity, proof of authority, PBFT, practical Byzantine fault tolerance. So there are so many consensus mechanisms we have, and based on this consensus mechanism, transaction is validated. And once the transaction is validated, this block needs to be added to the chain of blocks. So we call it chaining of blocks. For that, we use hash function. So we use cryptography at two places: initiating and broadcasting of transaction, and chaining of blocks. In chaining of blocks, we have hash function. Let's understand what this hash function is basically. In layman language, if you ask what is a hash function, I'll say that it is nothing but if you give any input, you will get an output of a fixed size. For that matter, if you consider the example of a modulo function, suppose you find modulo 5 for any number. Take a number 1004 modulo 5. What is the answer? Answer will be 4. Suppose 24 modulo 5, again the answer is 4. Suppose 14 modulo 5, again the answer is 4. Suppose 10002 modulo 5, answer is 2. So whatever number, how many, immaterial to the fact that how big the input is, the output will always fall within the range 0 to n minus 1. For that matter, if you use modulo 5, the answer will always be between the range 0 to n minus 1, that is 4. So this is a modulo function is a type of hash function. You cannot say modulo is perfectly a hash function, because modulo fulfills only one part of the definition of a hash function. Hash function is a type of function that maps any size data to a fixed size. So modulo does this part. But second definition of this hash function, again modulo will not be able to fulfill. So we cannot say modulo is a hash function. Just for our understanding, we can say modulo fulfills the first part of the definition of a hash function. Second part of the definition of the hash function is for any two different x1 and x2, hx1 and hx2 should be different. Means if you have two numbers 14 and 1004, modulo 5 gives you answer as 4. But for any two different numbers, two different x1 and x2, the hash value of the two x1 and x2 must be different. This definition is not satisfied with the modulo. So we cannot say modulo is a perfectly a hash function. So the biggest advantage for a hash function is it is a one-way function. Again, modulo solves this problem. A modulo is a one-way function. It supports this definition. Suppose you are given an answer 4 and you have applied modulo 5. Will you be able to ever guess what was the input number? Never. It can be 4, it can be 24, it can be 104, whatever it is. So you will never be able to guess the input if you are given the output. That is, it is a one-way function. So modulo also complements this definition of hash to be a one-way function. However, for two different values, we cannot have two different output in this modulo. So this hash function actually have a very important effect. We call this as Avalanche effect. What does this mean? This means that a very small change in the input will result in drastic change at the output. Therefore, we have this avalanche effect here. Even if adversary changes or the attacker makes a slight attempt to compromise this, it will be reflected drastically in the output. Means it will be evident that someone have tried to modify this particular data. So this is avalanche effect, and hash function must possess this avalanche effect. So here, let's have a look at how this hash is calculated. For example, this first block, how the hash for the first block is calculated, it uses 4 different things to calculate the hash. This hash represents the function that we apply over the 4 inputs. So 0, C1, TS1 and H0 is the input, and hash is the function, and the output is H1. So what this is, first it is a sequence number of access, then we have client ID, then we have the timestamp and the hash value from the previous block. Very important, hash value from the previous block. So with all these 4 input and this hash function, applying this hash function over the 4 input, we get H1. Now in the second block, again it have its own sequence number, its own client ID, its own timestamp, but it uses the hash of the previous block. And using all these 4 inputs, it again calculates the output using this hash function, and so on. So entire thing is hashed to connect it to the previous block. And if you make change in any one block, as discussed, it will result in drastic change everywhere. Then we have the properties of hash function. Like we said, collision free means if the two messages is different, the hash of the message should also be different. It is a one-way function. Very good. Given an output, you cannot guess the input, and it's puzzle friendly, complementing the hiding function or one-way function. Given an output, you'll never be able to guess the input. So these are the properties of a hash function. Moving on to the second cryptographic primitive that we use is digital signatures. So it is basically used to verify the content of the document, identity of the sender, and prevent non-repudiation. Very important. Suppose somebody, like in the example we have seen, Alice and Bob. Bob asked Alice to send this much amount to, suppose, Vector, send $200 to Vector. So Bob will, suppose, send $200 to Vector, and then Alice will deny to the fact that I have never asked you to send $200 to Vector. Why did you send this? Means refuting the claim of making any transaction, we call it non-repudiation. This is prevented with the help of digital signatures. We'll understand how. Only thing is, two rules are followed. Means the signing authority can only sign a document and everyone can verify the signature, and the signature is associated with a particular document, so you cannot transfer the signature from one document to another. So with these assumptions, the digital signature actually works. So these are normal cryptographic scheme. We know that we if you convert a plain text or message M into ciphertext or M dash with the help of a key by using some certain encryption algorithm. This process is encryption. Similarly, decrypting the message M from M dash with the help of another key and another decryption algorithm, this process we call a decryption. Now, what is important here? If you use same key for encryption and decryption, it is called symmetric key cryptography. If you use different keys for encryption, different key for decryption, this is called asymmetric key cryptography. Blockchain, we had seen that, relies on asymmetric key cryptography, means it uses different key for encryption, different keys for decryption. So two types of keys they use: public key, private key. Public key, as the name suggests, it is known to everyone and it is used to encrypt the message. So public key is known to everyone, used to encrypt the message, and private key, as the name suggests, it is kept private, it is kept personal, and it is used to decrypt the message. So the public key and private key, two types of keys are used, and this entire scenario works on the fact that if a message is encrypted using a public key of a user, it will be decrypted by the private key of the same user. So if a message is encrypted by the private key of a user, it will be decrypted by the public key of the same user. So under this assumption, this entire thing works. Let's understand how this is working actually. Suppose Bharat wants to send a message to Bharti. So everyone here knows the public key of each other. So what will Bharat do? Bharat will encrypt the message using public key of Bharti. So public key is known to Bharat. So he will be able to encrypt this message and he will send this encrypted message M dash to Bharti. Now, suppose there is some attacker here, some attacker, overhears this particular message, captures this message. Will he be able to decrypt this message? This message was encrypted by the public key of Bharti. It means that it will be decrypted by the private key of Bharti. And private key of Bharti is known only to Bharti, not to anyone else. Therefore, this message will not be decrypted by anyone else. Bharti will receive this message and she will decrypt it using private key. Iska private key? Private key of Bharti, and it is known to only to Bharti. So overall, this security thing is there, but how to prevent the non-repudiation? Bharat can somehow say that I have not sent the message. So we'll see how to prevent this, how to verify the origin of the sender here in case of blockchain technology. So it uses basically RSA algorithm, reverse Samir-Edelman algorithm, where public key is used to convert plain text to ciphertext. Ciphertext to plain text is done with the help of private key. Overall, I am not going to, this is the basic cryptographic algorithm. So I am not going into the details of this RSA algorithm. Overall, the output of this RSA algorithm is two things. We have two keys, public key for encryption and private key for decryption. So RSA algorithm generates two keys. Keep the private key with you and announce the public key to everyone. Now, what happens? Bharat, instead of sending only the encrypted message, what he will say, he will sign the message. Now, suppose Bharat signs a message with his own private key. So how will he sign? He will sign using his private key. Now, the Bharti will be able to decrypt the signature with the public key of Bharat, and if any message is being decrypted by the public key of Bharat, it means that it was encrypted by the private key of Bharat. And if the message is encrypted by the private key of Bharat, it is evident that this message is coming from Bharat only, because only Bharat knows his private key. Therefore, he is sending one M dash, that is the encrypted message, and he is sending a signature. So see here, M and M dash is encrypted by the public key of Bharti. So Bharti will decrypt M dash using her private key. So the security is guaranteed. and Bharat is signing message M and sending his signature and signing with his private key. So if a message is decrypted using his public key, he cannot refute the claim of sending that particular message because he has already signed this message. So in this way, security and non-repudiation both is guaranteed. However, we have some problem. We need to reduce the signature size. In order to reduce the signature size, we calculate message digest. So we use this message digest to sign. So what will Bharat do? He will sign the message with his private key, okay, and Bharti will verify the signature using Bharat's public key. So see here this equation, this HM he will calculate. Bharat will calculate the hash of the message, and using his private key, he will convert this encrypt this particular hash of a message, and he will send this signature to Bharti will verify the signature using Bharat's public key, and verify in the process of verifying this signature as he will decrypt this signature as using public key of Bharat. And if she decrypts this signature using public key of Bharat, she will get some message called some value called hash HM. This is the hash of the message. So Bharti is getting a message also, and Bharti is calculating a hash also. So she can calculate a hash of message M, and she can get a hash value from the signature, and she can compare both of these. And if this hash value is same, we say that the message is original. So what Bharat does here, he generates hash of the message, generated, signs this message using this hash using private key, signed, send it this signature along with the message. Bharti will first verify this signature with the Bharat's public key, and if the signature is verified using his public key, it means origin is verified. It is being decrypted by his public key, means it is he who has sent the message. And by decrypting the message, by decrypting the signature, she gets some hash value. She also gets a message. She will calculate the hash from the message also, and if both the hash is same, the content is okay. If the hash is different, it means the content have been altered. So this is how this cryptography plays a major role behind the success of this blockchain technology. Talking of classification of blockchain, based on the permissions we can classify, based on participation of we can classify. So permission, it is of two types, you can say permissionless and permission. So what do you mean by this permissionless? Actually, if suppose a node wants to join this blockchain network, join or quit the network, there is no need for any permission in permissionless blockchain. Anybody can join or quit the network without any authorization. So nodes use the common rules to receive, send, and validate blocks. And most common example of this permissionless blockchain is Bitcoin cryptocurrencies. Talking of blockchain, in permissioned blockchain, what we have, before participation in the network operation, all the nodes require proper authorization. So there is a need for effective network governance, and all the nodes are required to reveal their identity in order to participate in any kind of activity in the network. So this is the difference between permissionless and permissioned blockchain. Again, based on this participation, we classify blockchain into three types: public, consortium, and private blockchain. In public, some specialized nodes called miners are used, to collect and verify the transaction and add this transaction or the block into the existing blockchain. Example is Bitcoin or Ethereum. Consortium, in opposition to few specialized nodes, we have some predefined set of nodes that control the consensus process. Example, we have Hyperledger. And then private blockchain, the very important read permission public, write permission centralized to a single organization. So the read permission anybody can read, but writing is given to some single organization. This is private blockchain. Talking of generations, first generation, we all know that it was proposed by Satoshi Nakamoto in his white paper that was limited only to money transactions, and it was enacted in the form of Bitcoin cryptocurrency. Then we moved on to second generation of blockchain. Instead of only money transactions, instead of focusing only on money transactions, the blockchain now started focusing on assets and shares. So assets can be anything, you can say, for example, property or votes or goods. Therefore, because of the second generation, when blockchain started focusing on assets and shares and other things, the blockchain gained importance, and it is useful in huge range of application areas. For example, e-voting, supply chain of goods, and several other application areas related to, especially in smart cities. So this second generation focused on assets and share. And then finally the third generation emerged that was related to the smart contract. So whoever, suppose there are so many people who are entering into a contract, so this contract is first put into this uh, central server, and everyone is forced to follow this contract strictly. So this third generation significantly enhanced the blockchain capabilities, leading to the worldwide popularity. And this popularity is evident from this, growth of this exponential growth of the blockchain technology. You can see, for example, Ethereum grew 50 times in the last 2 to 3 years. Talking of ICO investment, it increased 16 times in the last 2 years. Considering the number of LinkedIn job postings, so this number of blockchain related job posting also tripled over the last year. You can see now you will be finding so many job posting related to blockchain. And then amount of global blockchain market is expected to be worth $20 billion USDs by 2024. Banks are also started experimenting with blockchain technology. Almost 69% or close to 70% banks have started experimenting with blockchain technology, and 33% of bankers are expecting commercial blockchain adoption by the next year. And reported potential annual saving for banks that utilize blockchain technology is 8 to 12 billion US dollars. So these are some of the stats actually that focuses, or that says that blockchain is growing rapidly, and it is the need of the hour at the moment. So the need for security, it is a paramount importance nowadays, especially in this internet of things domain and smart cities. So blockchain is something that support, that comprehends or that enhances the security of IoT and smart city systems, majorly because these IoT systems are resource constrained in terms of this having immature standards. They have resources diversity, and also some strict cryptographic mechanisms, security mechanisms cannot be employed because of some hardware and software design issues, development and deployment issues in this IoT system. Therefore, the managing of data in IoT is very, very difficult, and blockchain is something that can enhance these IoT systems, enhance the security of the IoT systems, smart homes, intelligent transportation system for that matter, supply chain management, healthcare, pharmaceutics, and you can say tracing of goods. So tracing in the pharmaceutical industry. So there are n number of application areas of blockchain nowadays. So it is very, very important, I should say. And these are some of the papers that I have published related to this blockchain scenario. First one is blockchain for smart cities. So this paper will help you understand the role of blockchain in smart cities. And then second is related to blockchain and Internet of Things. How this blockchain is useful for this IoT systems. What are the working models, and what are the challenges and future research directions that can be, that you can work in this field of blockchain and blockchain enhanced Internet of Things. And then third paper is untangling blockchain technology, that focuses whole and soul on this blockchain. What are the working principles of blockchain, how the transaction is realized in this blockchain, how a block is created and added, what is consensus mechanism, different types of consensus algorithms. So these are three basic papers that you can go through, that you can refer in order to understand the blockchain, role of blockchain in IoT and smart cities. My major research interests include wireless sensor network, security in communication, IoT, blockchain, and cryptocurrencies. Thank you, and apologies for being late initially.